Hey everybody, welcome back to another video. In this video, I'm going to be showing you how to divide polynomials. So in my previous video in 5.2, we talked about how to add, subtract, and multiply polynomials. Well, today we're going to be looking at how to divide polynomials. I'm going to show you the proper long division way of dividing polynomials, and then I'm going to show you a shortcut that applies for some polynomials. It's called synthetic division. But let's look at how to do long division first. Alright, so let's work on this page. Let's work number 2 here. So we're taking this first thing, x cubed minus 4x squared, and we're dividing it by x squared minus 16. And I'm using my mouse to write, so sorry about this. It's not going to be the prettiest. Anyway, okay, so this should look familiar, like, oh, we've done something with this box before. Oh, I remember long division. Well, it's the exact same process, except we're just using polynomials. Now, one thing I would do is for the polynomial that's underneath the box, I would go ahead and extend that and fill in missing pieces. So notice how we don't have an x in here. So for the x, we'll just do a plus 0x. And then notice we also just don't have a regular number, so we'll just do a plus 0. Alright, so I would do that for missing pieces, just put zeros, and it will hopefully help us out. Now, one other thing I'm going to do is move this down a little bit so we can write our answer on top. All right. So we're going to ask ourselves, what times x squared gives us x cubed? What times x squared gives us x cubed? And of course, that would be an x. So we're going to write an x up here. Oh, that's a terrible x. Let's try that again. All right, x times x squared is x cubed. So we'll write that under here. This is the same thing we do with long division with regular numbers. Then x times negative 16 is negative 16x. And we can see that we have to match these up. So the negative 16x isn't going to go here, because that would be unlike terms. You'd have x squared and x. So we're going to put the negative 16x right here. Okay. And then we're going to subtract. Remember how we did this back in the day? We're going to subtract. So x cubed minus x cubed is 0, so that's gone. Negative 4x squared minus 0 is negative 4x squared, so we'll just bring that down. And then 0 minus negative 16, you have to be careful here. 0 minus negative 16 is positive 16. Got that double negative in there. Positive 16x. Right? And then remember that we bring down that next number. So we're going to bring down the 0. Or in most cases, there would be something else already there. Okay, and then we're ready to do this again. So what times x squared gives you a negative 4x squared? What times x squared gives you a negative 4x squared? And of course, that would be a negative 4. So negative 4 times x squared is negative 4x squared. Negative 4 times negative 16 is, oh great, I think that's 64. Positive 64. Again, we have to match these up with like terms. Positive 64 will go right here. And then we subtract. The negative 4 minus the negative 4 is 0. 16x minus 0 is 16x. 0 minus 64 is negative 64. And at this point, we don't have anything to bring down, so this right here is our remainder. This bottom thing, 16x minus 64, is our remainder. And the way we write that, you may remember, is you take your remainder and you write it over this that's out front, this polynomial that's out front, like a fraction. So it gets a little bit sloppy, but here we go. Plus 16x minus 64 all over this thing over here, so x squared minus 16. And that is our answer. So this is our answer right here. X minus 4 plus 16x minus 64 over x squared minus 16. All right, let's do one more just for fun. Let's do this, this last one down here. So we'll write this first thing under the box. So we've got an x to the fourth plus 2x cubed plus 5x squared plus 3x plus 0. Remember, we're going to fill in that last little part because there's not an actual number on the end, so we'll just put a plus 0. All of that is divided by x squared minus x. Okay, now let's go ahead and do this. So what times x squared gives us x to the fourth? That would be an x squared. So x squared times x squared is x to the fourth. X squared times negative x is negative x cubed. And we can subtract. X fourth minus x fourth is 0. 2x cubed minus negative x cubed is 3x cubed. And we bring down the 5x squared. And we do it again. So what times x squared gives us 3x cubed? I think that would be a 3x. So 3x times x squared gives us a 3x cubed. 3x times negative x gives us a negative 3x squared. Okay, we'll subtract. 3x cubed minus 3x cubed is 0. 5x squared minus negative 3x squared is 8x squared. Okay, and then we bring down the 3x. All right, what times x squared gives us 8x squared? Of course, that would be an 8, so we'll put a plus 8 here. 8 times x squared is 8x squared. 8 times negative x is negative 8x. We can go ahead and subtract 3. Of course, these are 0, but 3 minus negative 8 would be 11x. And then we can bring down our 0. Okay, what times x squared? Oh, and actually, actually, that's it. Because there's nothing that we can really multiply by x squared to give us 11x. We could do negatives, but so this right here is going to be our remainder, 11x. Once up here you get to the regular number, like plus 8, or like we got up here minus 4, then you're kind of done with the regular terms and you're ready to add the remainder. So the remainder is going to be 11x. 11x over this right here, x squared minus x. X squared minus x. And there you go. That's your answer. Okay, so that is long division. I want to show you a shortcut as well, and this is this only works when we're dividing by something in this form, like where the first term is just an x, and then you have plus or minus some number. So notice all of these are going to be just x, plus or minus. So this shortcut only works with when we're dividing by some term x plus or minus some number. Okay, so this right here has to be an x. And this method is called synthetic division, and it's really quick and easy. What we do is we take the number that's over here and we change the sign. So instead of -2, it's going to become a 2. Then we draw some kind of weird box, kind of like this. And we take the coefficients of the first polynomial. So we have a 1, -10, and a 2. All right, and then what we're going to do is we're going to bring down the 1 down to here. Multiply these. 2 times 1 is 2. Okay, add these. -10 plus 2 is -8. Multiply this right here times -8. 2 times -8 is -16. Add again, we have -14. And this is your answer. I want to make sure that I give it to you in the right way. So let's do that. All right, so the answer is this last little bit right here, the last number is going to be your remainder. So this is just going to be your regular number, and this will be an x. Essentially, whatever the degree is on the first polynomial, your answer is going to start out with a degree less. So this is going to translate to just an x, 1x minus 8. And then this is your remainder, so it'll be minus 14 over whatever that second polynomial is, so x minus 2. And you're done. So let's do one more real quick. So take that number right here, change the sign, so it'll be a -2. Draw your kind of little box here. Take all of these coefficients, 1, 4, 6, and 4. Let me make sure. Yeah, okay. All right, and then you're ready to do this. So bring down the first number, so 1. Multiply these. -2 times 1 is -2. 4 plus -2 is 2. Multiply -2 times 2 is -4. Add these. 6 plus -4 is a 2. Multiply -2 times 2, which is -4. And notice that gives you a 0. So we're actually going to have a remainder of 0. So this is going to come out real nicely. So this is, our degree is going to start with x squared. So this will be 1x squared plus 2x plus 2. And then our remainder is 0. So we have 0 over x plus 2, which is just 0. So we don't even have to write it. This right here is our answer. So you can see how quickly synthetic division is. Now we can also, let's see, actually equivalent expressions. This is just going to be more of the same. We can also evaluate functions for a specific x. So if they tell us what x equals, then we can actually evaluate these functions. Let me just make sure that I'm telling you right. All right, so the way you do this is the same thing. Use synthetic division. So you're going to take that 2 and stick it out front. This time you don't change the sign with these. At least I'm pretty sure. Let me make sure. Yeah, you don't change the sign. So you just stick a 2 out here. Draw your little box. And then all the coefficients. So -3, 4, -17, and negative 6, and then just do synthetic division. So bring down that negative 3, multiply. 2 times negative 3 is negative 6. Add, so that'll give you a negative 2. 2 times negative 2 is negative 4. Add these two, so you'll have a negative, what is that, 21. And then multiply. 2 times negative 21 is a negative 42. Add these, and you'll have a negative, what is that, 48, negative 48. And this last number right here is the answer. So if you were to plug in 2 into your x's and evaluate this function for x equals 2, then you would get negative 48. So you can actually use synthetic division to figure out what the answer is without like having to plug it into a calculator. Or I think it actually makes it a little bit faster and a little bit easier. Anyway, so this is actually called the remainder theorem, but you can use, guys, the remainder theorem to figure out when you're trying to evaluate a function for a specific x. Anyway, guys, I hope that this video helped y'all out. I hope it made sense. But I'm going to leave it off for there. So y'all take it easy, guys, and I'll see you in the next video.